The holy grail of a science experiment, why we have that whole philosophy of science feeding into the scientific method, is to establish predictions about the world, to be able to predict future behavior from past behavior. Can we study the motion of the planets and know where to expect them to appear again in the night sky? Can we study human behavior and predict how humans are going to act under other circumstances? So in one viewpoint, the goal of science is to make causal claims, to make a claim about one variable causing another variable. And what I'm mostly going to be focusing on here is critiquing how the media reports on research, both personal research and scientific research, and how we often mistake what looks to be a causal claim is actually a frequency or association claim. So what are these different types of claims? How do we get there? And why is a causal claim a high bar for us to get to? So one of the biggest mistakes in the class is to see a researcher legitimately making one of these claims but mistaking it for another. Causal claims are the most tricky. That is the highest bar for us to get to. But before we get there, frequency claims are just one variable claims about how frequent something is, how often it happens, the proportion of people that do something, etc. An association claim takes it a step further and involves two variables. An association claim is how one thing is related to another thing, right? And people most often take an association claim and mistake it for a causal claim. Often in science, we can pretty reliably see that two variables are related to each other somehow, but establishing that one of those variables causes another is trickier, right? On this slide, you're going to see three examples, all from the same news story about a scientific researcher. One of them is a frequency, one is an association, and one is a causality claim, all three from the same article. If you want the answers, they will be posted with this video somewhere, and if you want to read the story, it's also on the class website. It's pretty interesting. So frequency claims, they're the easiest to make. 4 in 10 teens admit to texting while driving. In one study on moral behavior that I read recently, 84% of people pressed a button to shock a mouse if pressing that button prevented 5 mice in an adjacent cage from getting shocked. This shocking statistic and others in this category tell you how often or how many, but they don't tell you the cause. We don't know with those numbers why teens are looking at their phone while driving or why people are choosing to shock one group versus another group. These claims are only about one measured variable. People with more expensive cars are less likely to stop at a four-way stop sign. Romantic partners who express gratitude are more likely to stay together for longer periods of time. These are association claims. Association claims are claims that one variable is related in some way to another variable. Now, the good thing about association claims is it's pretty easy to establish this in the field. We know, that those results that I said earlier were based on real examples that we've determined through simple just assessment of our environment. We know those things are true, but we still don't know with the expensive cars and stopping at a four-way stop sign. Does having an expensive car cause you to be less likely to stop? That's more difficult to establish. Romantic partners can express gratitude, and maybe expressing gratitude causes you to have a longer relationship. But maybe it's the fact that being in a longer relationship, you will develop better ways of expressing gratitude. Maybe we can infer that one of those things is more likely to be true, but we just don't know based on that data alone. One common, in fact, the most common when you do statistics in this class and other classes, way of measuring an association between two things is a correlation. Just a quick reminder, in everyday language, a correlation literally means correlation. When two things happen at the same time, when one variable is related in some way to another variable. In statistics, correlation means a specific category of associational statistics. You can assign a number to the relationship between one variable and another variable. We'll look at that in a future video if you need a refresher on correlations. I know many people won't. Causality is when we have determined a relationship between two variables and we have a degree of certainty that one thing is related to another claim, or we'll say one variable is related to another variable. A few causal claims that I've seen in the media recently. Violent video games cause more violent behavior. A black hole devouring a neutron star caused ripples in space and time. And glaciers in Greenland are melting at an unprecedented rate and will cause an increase in global sea levels if the melting continues. These are all causal claims that have been made in the media recently. They're not just that one thing is related to another thing, they're that the first variable is causing the second variable. In order to determine, by the way, I don't think all those examples are necessarily accurate, because one is a prediction and another is based on behavioral observations that are not backed up by science. But anyway, still examples from the media, right? This is partly, you should be able to critique the media going through this class, right? Not all of those are accurate. But anyway, when we go from an association to a causal claim, we have established some degree of certainty that one variable actually is causing the other variable. Part of the way that we should be learning to establish that causality is through the experimental method that we're going to be talking about throughout the class. It's a higher bar to hit than an association claim. Many claims reported in the media, blogs, whatever, are not research-based, and that is okay. We're talking all the time about the privilege that the scientific method is given in this class, but you can report on an inspiring story or something important that we, the public, have to recognize when a story fringes on science but is not science. Science and research aren't the only way to get knowledge about the world. They just have particular advantages. Quickly, this was in the news today, found this story. The reporter is not doing an irresponsible thing by telling you that this teen does blame vaping for his lung collapsing, and his doctors told him that his lung collapse that he had to go to the hospital for. It was a very scary situation. There's probably a relationship between that medical event and vaping, right? It's not proven by science. Nobody did an experiment. This kid's full of crap, right? That's not the takeaway from this, right? His personal anecdote is still important and still newsworthy, but we have to take a step back and understand that until this claim is scientifically evaluated, we need to take it with a grain of salt. It's possible that that relationship is spurious, right? It appears to be a causal relationship, but we are making a mistake. That's what science is for, right? Science, being a systematic way of investigating the world, is less prone to error than making judgments based on our intuition. So that's where we're going to end this video, but look for information about correlations, and we're going to do some more stuff with these claims that we're making in future videos.